The topic of my presentation is loading. Oh, there we go. So, as you heard, I work for GoDaddy, and here's some of my team members. And so, Website Builder, as I was saying, was a rich WYSIWYG application for non-technical people to easily create their own website. And we happen to have 1.3 million websites currently. And there's hundreds of templates for 16 languages in 37 countries. And it comes with all kinds of add-ins like social media integration and SEO features. So I want to talk to you first about how things used to be for this product. This was our feature development cycle. So let's say the top line is master. We would create, because we have a large team, we would divide into feature crews, and we would each create our own branches. And then for our sprint, we would work on the branch, and this would be for a good 2 to 4 weeks. And of course, then once you're ready to release, we would do a merge into master. Now, these other branches, they need to get the latest code, so they merge from master. And they have no idea what this crap is that they're merging in. And they get all these merge conflicts, and they break all their tests, so they have to fix all of their tests. And once that's finally good, now the purple team's ready to release, and the whole process goes on all over again. Really painful. But that wasn't the worst of it. This is how we actually got our code out to our customers. First, we would have a QA department that would manually test in the test environment. Then we'd copy the files to a staging environment and manually test there. Then we'd fill out this change order form. We'd get peer approval, QA approval, manager approval. They all had to sign off on this form. And then we'd ask ops to pull out half of the servers from the load balancer, then ask them to deploy files to the ops servers. I'm getting bored saying all of this. Anyway, 16 easy steps, and we're finally in production. And nobody has time for that. None of us really liked this at all. Deploying code would take all day long almost. And it would take at least 2 weeks to get things out to customers. Sometimes more, depending on how long our sprint was. Because of all this manual testing, you can only do so much just through interactive testing. So we had pretty low code quality and, of course, a high level of frustration, both from customers and from us as developers. See, everybody knew this could be better, but you really have to take the time. You have to invest the time and money into fixing the problem. So, luckily for us, an opportunity came along. We were tasked with the re-architecting the backend to be a Node.js API. Part of the reason why is because of us going international, and we needed to change the whole way our data was stored so that we could replicate across different data centers. And plus, we wanted to have less friction between server side and client side. As you can imagine, it was a very rich JavaScript front end, so having to write our code on the back end in .NET, we would much prefer to do JavaScript on both sides. And we were given permission to do things the right way this time, because we had accrued a lot of technical debt. So what our team wanted to do is, for our development lifecycle, we wanted to have CI/CD. And as you probably know, CI stands for continuous integration, meaning that you're constantly checking code into the master branch instead of these long-lived feature branches that we were working on. And continuous delivery is ship it out to the customers as soon as you're done with checking into master. So I was kind of skeptical about this at first. I was used to this process that we were using, and it kind of felt safe, right? Like, okay, well, we're double checking and triple checking everything. And we're making sure that it works before we get it out there. And it's true that we couldn't just flip a switch and say, hey, now we're going to start pushing code out to our customers, because we weren't prepared for it. We have to do a lot of groundwork in order to make CI/CD a reality. But now we finally have done it, and we have continuous integration, continuous delivery. And the great thing is, I can confidently check something into Git, and about 5 minutes later, the bug fix or the feature is in production. So for anyone else that doesn't yet have a CI/CD system, I want to talk about how we do it. And maybe we can share some ideas. So the first really important thing that we need is a better collaboration platform. Continuous integration isn't so much a technical problem as a social problem, because it's all about communicating with each other. So these are the tools that we selected for ourselves. We love the way that GitHub works for our open source projects, so we wanted to bring that into our enterprise. And GitHub Enterprise, it allows you to install your own version of GitHub, and you can customize it for your own needs, and you can have your own projects that aren't yet open source protected in the corporate network. Slack is another big one for us. We had Instant Messenger before, but there's not a lot of persistence there, and you have to invite people into the conversations. You end up having these siloed conversations, and the whole team doesn't have visibility to what's going on. So Slack is kind of like an IRC chat room. You have these channels you can join, and it's heavily searchable. So this is a great place to do design, code design discussions, and pretty much any other discussion. And just plus do a lot of announcements for the team. And of course, we needed to track bugs. So we're using Jira for that, because it allows you to do the agile board, like the Scrum boards or the Kanban boards. So once we had this collaboration platform in place, now it was time to tackle our development process. So we decided to go with the GitHub flow, which if you're not familiar, this entails making a branch off of master. You add commits to that branch, create a pull request, and then this pull request needs to be code reviewed. And once everything passes with the code review, then you merge into master. So many people in our team found this kind of strange. Isn't the purpose of a pull request for the maintainer of the package to say, yes, this is good, and some people want to use just an over-the-shoulder code review, like, hey, come over here, look at this, and then they talk you through the code. So the reason why we're going with pull requests is if somebody's just looking over your shoulder and you're doing a code review, you're kind of guiding their thinking. You're telling them exactly what the code does, and then when they look at your code, they see it. And what's nice about a pull request instead is your code needs to be self-explanatory. Somebody needs to be able to look at the code and say, okay, this is what it does, and it makes it easier for them to see problems with it. It also gives you a good documentation trail. So you can see exactly what everyone's discussed for each pull request. And plus, there's visibility for the whole team. No more of this, hey, these two developers are working on this feature. They understand what's going on. It makes sense to them. They pass the code review, but the rest of the team has no idea. So we annotated the GitHub flow a little bit to fit our needs. And a lot of this is pretty typical, but first off, when we branch off master, we try to make sure they're short-lived. This way we don't have the merge hell that goes on oftentimes. When we add the commits, try to squash them down so you have typically a single commit per pull request. The reason why is nobody wants to look through a history with hundreds of partial check-ins because it's not very helpful. Your Git history should be a good trail about exactly what's changed. When we create the pull request, we try to be very descriptive. And when you have a code review, it can't just be a code review where you're looking at style over substance. It has to be a substantive code review. Like, how will this perform? is this doing the right thing for customers? And step 4.5 is to add automated quality checks, and I'll talk more about that later on. And then after we merge into master, we have an automated deployment. Okay, so let's talk about what I mean by quality checks. So people are lazy, and developers are especially lazy. This is actually a good thing, right? This is why we will automate something that's fairly tedious and make it more efficient, because we just don't want to do the work. But the bad thing about us being lazy is we won't run tests, we won't run quality checks unless they're really easy to do. So the way that we do this is we use NPM. So one quality check that we need to take care of is linting. And we're using JS hint, sorry. And putting this into an NPM script is super simple. You see here in the dev dependencies, you just give it to JS hint. And then in the scripts, you can have a lint script or put it in your pretest. And what's nice about JS hint is in different areas of your code, like let's say in your tests, you might have different style rules. So if you put a .js hint rc in each directory, then different rules will be applied to that directory. And also what's nice about JS hint rc is it's such a well-known thing, so that if you have an IDE or something like Sublime Edit, it's got good integration. Sublime Text, yeah. It's got good integration, and we'll put squiggly lines underneath the text. And everybody hates squiggly lines, so they'll fix any sort of problems that it finds. So I kind of find linting boring. Like, so what? Like, who cares if it's 2 spaces versus 4 spaces? Who cares where the curly brace is? But this is what I like about linting. You don't have boring diffs like this. You see here, nothing's changed at all, that you have this enormous diff. It's just because you'll have edit wars for different styles. So JS hint will put an end to that sort of thing. So the next quality check is unit testing. Now this has been somewhat controversial lately. Well, maybe it's always been controversial. So many people are asking the question, is TDD dead, or is unit testing dead? Well, here's the thing about unit testing. It's mostly there to aid us as developers. It doesn't tell us if the system works. But I think that unit tests are a really good thing still, because they document how the code is supposed to work. And this helps you communicate with other developers in your code base. It also helps you refactor with less fear. But it's definitely not enough for having a continuous deployment. You need to know the overall system works, not just that your code works as designed. So in my opinion, for full stack applications, CD is impossible without good integration tests. So I'll briefly go over our testing stack. We selected Mocha. What's great about Mocha is you can run the tests using Node. It has its own executable, and you don't have to have a HTML host for your tests. And if you use Jasmine, it looks very similar to that. With the BDD syntax, you can have nested describe statements, and then it statements that assert things about your test. And you can do a setup for these different describe blocks. And it has good support for asynchronous code. You'll see here for this last test, there's a done function, a done parameter. And you can call that if you're asynchronous, once your asynchronous code is done, so that the test framework knows that it's done. And what's great about this BDD style is it will append all of these descriptions together and just form sentences. So you have something that's very readable. Now, Mocha doesn't come with its own assertion library. I think it comes bundled with should, but we decided to go with chai because it's more pluggable. So to use chai is as simple as requiring it. And if you want to use the expect syntax, you just say chai.expect. And as you can see, you have a really fluent way of making assertions, expect some value to equal something. It's kind of weird, I think. Some of the assertions, they just end in a property like that, but that's actually valid. It must have like a property getter or something. There's also the should syntax, which you'll see below. Should's a little awkward because you can't say a null value dot should, otherwise you'll get a null reference exception. So sign on is what we use for our stubbing and for basically our mocking. And this is really helpful for unit tests that if you need to talk to a database or you need to talk to a web service, it's really great for being able to synthesize what the web service will actually do. You'll see here in the bottom test, we have our mock object, and we're saying this method yields these values. So this will let you really get to all of the edge cases in your code without needing to write a bunch of different test cases or to set up a database or anything like that. And this works to tie it in with node modules. We use proxy_quire. And the way proxy_quire works is it will intercept any time your code does a require. It has the ability to inject a mock object in its place. And then for our UI testing, we're using Selenium. Right now we're doing this in Ruby with RSpec, but we're hoping to move this over to JavaScript as well. And Selenium, if you're not aware, is a great platform for testing in multiple browsers. And it's got good primitives for doing things like mouse overs and clicks. So integrating tests with NPM is pretty simple. You just create some scripts. And you'll see here that I created a separate one for integration, and I created another one called Smoke. The reason why is integration tests can be really, really slow. And sometimes you can make have the mistake of having an integration test suite that runs and takes hours and hours and hours. And the whole point of CI/CD is that you can get your changes out there really quickly. So it's kind of a matter of balancing between speed and thoroughness in your tests. Because your integration tests are so slow, you should, when you run them, you should cover the main scenarios only and use those unit tests for the edge cases. And if you have more rare branches in your code, you can maybe run those on a case-by-case basis instead of for each check-in. So the last thing about code quality is something called test coverage. It doesn't really tell you if you have enough testing, but it does help you to tell you what you're not testing, if that makes sense. For this, we use something called Istanbul. What it will do is it will convert your JavaScript code. It will instrument it so that it can basically log everything, every way that it's called, every statement, every if statement. And then it collects it all into a report. So you see here, I have a coverage script, and you simply run Istanbul cover and give it the tests, and then use Mocha to run it. And that the report will give you something like this. It will tell you exactly which lines have been covered and which have not. You can drill. This is the top-level report, and you can drill down into the actual code. And if you hover over these info icons, it will tell you more information about why that's not covered. So we are doing hardcore mode for code coverage. You can see here we are requiring 100% coverage for all statements, functions, branches, and lines. That's how into testing we are. And we're very glad that we did it. It can be kind of a pain at times, but it kind of gives you that that assurance. But sometimes there are certain blocks that just aren't worth covering. And so there is a cheat code where you can put a little comment and say, ignore this next thing. Okay, so now we talked about the quality checks. How do we tie this all together with our process. Basically, we never allow a merge into master unless all of the quality checks pass for a pull request. And that's actually a little bit more difficult than you might think. Integration tests are particularly a difficult thing. Sometimes you're calling web services that will time out or get an intermittent error, and those can be really frustrating. And the thing is, everybody has to take responsibility for these. This will block your development process when they occur. But keep in mind that customers will experience these same frustrations if your integration tests are running across them. Our hundreds of thousands of customers are also going to run across them. So this forces us to make it a priority, talk to any other teams, if we're working with some sort of internet service, reaching out to the support channels. This really makes sure that it's not just our code that's good, but it's the entire system that works. And of course, after we merge into master, we also will never deploy to production unless the quality checks pass for the merged code. So the way that we do what we do is pull request integration. And this is a very convenient technique where after you create your pull request, you'll automatically get this little window in your pull request. It starts a build. In JavaScript, you don't really have to compile things. But by build here, we mean a test run. We run all these quality checks. And if it succeeds, then it tells you all is well, merge build finished. And then after you've had all of your +1s in your review, then you can merge that in. Or if it fails, you can look into why it is and fix it. So there are other techniques for getting this in, but what we use for those pull request integration is Jenkins. Jenkins has a plugin where it can intercept new pull requests from GitHub or GitHub Enterprise and kick off a process. So our Jenkins build checks out the commit, does a lint, does unit testing, local integration tests, remote integration tests, and then it shows the status, of course. So what do I mean by remote integration tests? What I mean by that is we don't only want to just run the integration tests for our development environment. We actually want to test it against production. We want to see will this actually work for our customers. So how do we do that? So this is the technique we use. Our Jenkins build does a secure copy of the branch that's being tested. Here you can see Git hashes for all of these different versions. And the one that's bolded here is what's called the default. So we copy this out there, but it's not active. However, our code has a router where if you pass a HTTP header, like xgit hash, now all of the requests will actually be run by this version that's not live. So this is how we can actually test with our production database, production web services, all of that without going live yet. So once everything passes and you do your merge the pull request, it goes through that same process again, except for this time it will check out master, run through all the tests. And this time around, it will promote the hash. And hey, now we're live. And we're done, right? Well, not so fast. So what's the point of continuous delivery? Is it just making us programmers happier through better automation? Well, it does make us happier, but that's really not the real point. The real point is to enable rapid delivery of value to customers. Now, what's meant by value? Value does not mean, hey, our tests passed, here's our code, you're welcome. No. The tests will only find bugs that you've thought of. So there may be other bugs that are still present. And even if your code is correctly functioning, it might be badly performing. And if it's really slow, the customers aren't even going to want to use this new code. Correctly functioning software only matters also if customers actually want to use it. You may have a feature that you think is cool, but customers might find it useless. Basically, continuous delivery is useless without continuous feedback in place, which is where you write your code, you deliver it, you collect feedback, and then you use that feedback to make decisions for other code that you write. So important things that you have to have in place is, first off, logging. You need to be able to log not only errors that take place, but you need to be able to trace any sort of requests that are going on so you can analyze trends, collect diagnostic information, and that sort of thing. So we're using the so-called ELK platform for our logging. And that's an acronym that stands for Elasticsearch, Logstash, and Kibana. And these are easy to get confused, but basically Elasticsearch is the part that does the analysis and the searching of the log data. It's super fast. Logstash is a distributed storage where you can actually put the log data. And Kibana is a user interface where you can see a list of all of your errors, and you can make graphs and other pretty things for managers to look at and whatnot. So in the Node world, it's really easy to use Logstash. There's a package called Winston, and it's a general purpose logging library, and you can plug in different backends for your logging. So if you would npm install Winston Logstash, that gives you a really easy way to get things into your Logstash. You also need monitoring. So we went with New Relic, which has been a really great product. So what New Relic will do is it will tell you the CPU usage on your servers, how much memory you're using, but also it will tell you how long each request takes. And it gives you these nice stack graphs. So you could say, for example, this is how long our code takes. This is how long our database request takes. Here's a service that we're calling. That's how long it takes. So with this great visualization, that will let you drill down and say, what are our bottlenecks? What do we need to optimize? And New Relic also has integration with the client side as well. You can report, you can have real user monitoring. Google Analytics is another thing that we use. This is what helps us know what exactly users are doing on our site. We can look at trends and say, we can see which events followed which. And this is really great for product managers to know to make informed decisions, data-driven decisions about what are the most needed features, what are the biggest pain points for our users. So one big objection that we had for CI/CD, one thing that seems really scary is sometimes you have a feature that takes a long time to complete. And if our feature's not done, we don't want to commit it all the way to master. So also, sometimes there's a feature that's a little too risky to release to all customers, and we're afraid, like, are we going to make all of our customers mad if we push this out there? Well, the CI/CD way of alleviating these concerns is to use a feature flipper. And then you can roll out your feature gradually. And this is also really useful for doing A/B testing. So I love this mascot. GoDaddy has actually open sourced a product that we use for feature flipping called Flipper. So you can install it simply with an npm install. And this allows you to do both configuration and feature flipping through YAML files. So here's an example. Here you can see in this example, you can actually assign different percentages to different configuration values. And you can do overrides and say, for these specific users, we want them to get this feature. And plus, it's pluggable. So if you have your own sort of bucketing logic that you want to put in place, it allows you to do that. So this, in conjunction with things like Google Analytics, will help you. Let's say you want to release first to 5% of customers. You can monitor, see, does this perform well? Look at Google Analytics, say, are people actually using this? So this is a great way to mitigate risk. So one final point I want to bring up, keeping this sort of system up and running is difficult. Oftentimes, these build scripts will stop working. You'll experience problems with the build server or the logging server. And it's super important that this isn't a volunteer effort. It doesn't come for free, right? When the build server's down, you need somebody that's responsible, that can say, yeah, I'll fix this, that's my job. If it's just a volunteer effort, then you might feel like you're too busy, and you start to ignore the integration tests or start manually pushing things out. And that's when chaos occurs. So it's very important that you have build engineers, engineering support in general. All right, that's about it for me. We've got all kinds of things that we've been putting on GitHub as we develop them. Particularly have a lot of things to help out if you're doing any sort of Cassandra database operations. Flipper, of course, is there as well. And yeah, we look forward to you sharing with our code and seeing your pull requests. And obrigado. Thank you for your time.